graph the function of f by starting with the graph of y equals x squared and using the transformations shifting, compressing, stretching, and or reflecting. So for this problem here, we got this f of x equals 2x squared minus 4x plus 1. What we need to do first is we need to put it in the form of, in standard form they called it in this section, but it's also called vertex form. So we're going to get it in that form of HK. So what we're going to do first is let's write it out. And what I'm going to do is I'm just going to pull a 2 out of the first two terms, the variable terms. And I still have a plus 1 here. As you see, just factoring the 2 out that way, it looks similar to that form already. What we're missing here is in here, this has to be a perfect square trinomial. So we're going to use the idea of completing the square here. And we have to use it in a creative way because we don't have two sides. So if I add 4 here, I'm not going to be able to add 4 to the other side because it's the function that's equal to it. We don't have that other side here. So it makes it a little more complicated to think about it that way. And that's where a little more creativity comes in. And you're going to see it as we do it here. So what I'm going to do with this inside of here is I'm still going to take half of the b and square it. So I'm going to take negative 2 over 2, and then I'm going to square that. And that's actually going to equal, oops, I should say positive 1. Okay, so what I'm going to do is I'm going to have to add a 1 in here. So let me use a different color so you can see that. So I'm going to have a plus 1 in there. But really what I'm doing is I'm actually adding a 2 because this 2 outside of here, I'm going to have to times by that 1. And that's actually going to give me a 2. So I'm really adding a 2 here. That's the idea. So if I'm adding a 2 in here, I'm going to have to subtract a 2 out here to offset that 2 I added. So really what I'm adding is 0. Now I'll write this out so you can actually see this. So this is really just going to be f of x equals 2 x squared minus 2x plus 1 minus 2. And if I distribute this here with that one, that's going to give me a positive 2. And then when I combine like terms, it gives me the 0. So that's where that plus 0 comes in at. So what I get here when I put those together is I get a minus 1. Now, this is a perfect square trinomial, which means now I can factor it, and it'll look exactly like the first problem we did here. So this is going to be 2x minus 1 squared minus 1. So now that we have it in this form, we could talk about the transformation very easily. Now, what I'm going to do first is I'm going to graph the original, y equals x squared. So then now from here, I'm going to graph the y equals x squared. So there it is. So what we're going to do now is we're going to graph this transformation. So if I look at this here, this means I'm going to shift to the right one because 1 makes this 0 here if I plugged it in for x. Or remember, it follows that form. So my vertex is going to move to the right one. So it's now going to be there. And then this tells me I'm going to move down 1. So I'm going to deal with that next. So now that means I'm going to go here. That's where I end up if I'm going to move down 1 also. So that's where my vertex is now going to be. So I'm just going to write that in there. So it's going to be here. And when I move to the right, notice this, I got to times it by 2 instead of a 1 like I normally have in front of x squared. So I get this vertical stretch of 2. So I move it up 2 when I go over 1, and I do it on both sides. So now, this is the idea of what I get here. And as you can see, if I drew it correctly, it would be just a nice shift over and shift down. And it's not flipped over because there's not a negative on the A there. So this is what we call a vertical stretch. Now I'm just going to write down all of the description of this transformation, which is an important thing to understand. So now what I'm going to say first is I'm going to shift to the right 1. Okay, that's the first thing. And then I'm going to shift down 1 and I would say a vertical stretch of 2. And that's how we would write the transformation if we were asked to write it out. And when you look at this, they want us to use the transformations to actually graph this, and that's what we did. So first of all, we put it in the vertex form or standard form, whatever you want to call it here. That's down here, excuse me. That's where it's completed. And then I'm going to use that to talk about what the y equals x squared is doing to be the new function that we actually graphed. So there it is.